Hello, friends. We are here at Google I/O at Shoreline Amphitheater. I'm your host, Arthur Soroken, co-founder of the AI Futures Fund. AI Futures Fund, if you don't know, is a place where we strategically invest in startups, partners, companies, etc. They're all building the future of AI. If you tuned in yesterday and saw the keynote at Google I/O, I saw a lot of good 0 to 1 innovation coming out of Google products. So you saw Omni, you saw Gemini Flash, 3.5 Flash, 3.5 Pro. So all these great products that are coming out. But I'm not here to talk about that today. I'm actually here to talk about all the 0 to 1 innovation that's actually happening outside of Google. So I have a good, some family friends, some AI Future Fund portfolio companies here to talk about some of the 0 to 1 innovation that they're doing. And so I'm pretty excited today to introduce my first guest, Matt Rogers. Matt Rogers is the CEO and founder of Mill, and previously was the founder of Nest. And so Matt, welcome back to Google.
It's good to be back at Google I/O.
How many I/Os have you done? Let's start there.
I think I've done 3 or 4.
Okay.
Yes.
That's good. You're a
I've done 3
veteran.
or 4. Yes.
Okay. Favorite launches so far that you've heard?
Ooh, today, let's see. I'm really excited that Google's going agentic. I've been using OpenClaw and I'm scared to death of it. And I'm really happy to have Google step in with their security-mindedness to build something that's going to be safe for us to use.
I love that. Good. But let's jump in. I mean, there's a lot of people listening, etc. And as a fund, very curious of people who are starting from the beginning at the ideation phase. I'd love to hear a little bit about and share a little bit about Mill and kind of how you got started.
Awesome. Yeah. So building a new company, Mill, we're 5-6 years in now, and we're tackling food waste, which is a really hard problem, and it's everywhere. Most people don't realize, we throw out 30-40% of the food we grow. It's a multi-$100 billion problem. It's 10% of global emissions. So massive scale problem. And actually it's one where the combination of hardware and AI really are perfectly suited to solve. And we'll talk about some of those things today, but we're building both products for the home, but also for businesses to help them manage and save on food waste.
Incredible. I can't help to wonder, and I've been wanting to ask you this, and we were talking a little bit before this. I have to ask, if I look at Nest and I look at Mill, I'm very curious. Do you start with the problem? These are both, these products are mundane products in the house, potentially, that you're walking around. I'm actually really curious, do you start with the big problem? Do you start with the mundane thing in the house? Where do you start?
I'm very problem-centric. And I think about going way back to why I became an engineer, as I was a 15-year-old thinking about what I want to do with my life. I became an engineer to solve really big problems for humanity. And I started at Apple many, many years ago, was one of the first engineers on the iPhone, helped build that product and that team up, and was really looking for what are big, meaty problems that could use a lot of the technology we used on the iPhone. And that's what led us to Nest. Home heating and cooling,
right.
Major energy use,
right.
People are uncomfortable, products really suck in that space. Right. Surely we could do a lot better. And we built that company. I joined Google for many years, helped transition Nest to Google, and have been looking for similar problems like that out there. What are these other massive planetary scale problems that could use hardware, software, and AI to solve it? And food waste is one of these in spades. We deal with it every day. It's icky and gross. It's something that we just try to get rid of, but actually it's very valuable. And the more we measure it, the more we can manage it. And part of what we'll talk about today, in terms of how we're partnering,
yes,
is how we're going to manage it.
Great. I mean, let's not waste any time. Let's jump into it. I'd love to hear about, let's start with how does it work?
How does it work? Okay, so it's a giant scale dehydrator. So food is mostly water. Most people do not realize this. Food is 80% water. So when you take the water out of food, it gets powder fine, looks like coffee grounds. So it's light, doesn't rot, doesn't get gross, easy to transport, easy to recycle into food or into compost. But what we've learned is actually yes, it's great to be able to manage food and get it to the right place. But ultimately, can we prevent food waste altogether? And that's where the partnership is really shining with Google. We're working to build custom visual models. So using computer vision, using AI, to identify what food is being wasted as it's being thrown into our machine, so that we could very quickly say what it is, why it happened, when it happened, to tell grocery stores and restaurants how they could prevent that waste altogether.
Incredible. And I mean, when we think about it, like, what are some of the Google and technology things you're using? When I think about, recycler, food waste recycler, I don't think about AI. It doesn't naturally come to mind. I mean, what are you using under the hood? Like, let's get into some of the details.
Yes. Okay. So, I mean, for a trash can, this is about as sophisticated as it gets. So we have a high frame rate camera. So like this thing is capturing 120 to 240 frames per second. Like a person could not go through frame by frame. So again, perfect use of AI. And then we're trying to do this all on device, which is a really tall task. I think back to my Nest days when we did Nest Cam. We were streaming video to the cloud 24/7, and we were running those algorithms, that AI, that generation in the cloud. It was incredibly complex and incredibly expensive to do. And that was just for the tens of millions of Nest cameras that are out there. Think about the quantity of trash we're throwing away as a species. We could not do this in the cloud. We would need to build more data centers.
Right.
So we're putting a Nvidia Jetson in our trash can, pairing it with this camera, and running Gemma on the device in the grocery store, in the restaurant itself.
Right.
So think about like hand-tuned custom versions of Gemma that we're building in partnership with you guys to be able to do this better than anything can be done off the shelf.
And I mean, as people, as builders out there that are, looking at cloud-based solutions, edge solutions, Gemma versus, the next version of Gemini, et cetera. Like, how do you think about those trade-offs? And I mean, on-device Gemma makes total sense, but you got to do some work. It's not right out of the box.
Cost, complexity, accuracy. It really also depends on the task. For example, I think about like, for a medical application, you don't want to make the wrong call. So like having the most complex, sophisticated, deep thinking model makes a lot of sense. But something where like you're more rapid fire, where like if you make a mistake, it's okay, you could correct it, different story. And for our application, like if you identify an apple versus a tomato, we're like, it's not the end of the world, but if you start adding those up over time, you're gonna make a bad procurement decision as a grocery store. So actually, maybe that's a good segue.
Let's demo.
Let's go to the demo.
Great.
This is gonna be fun here. Open up my laptop here, and what we have here is our tool that we are using to benchmark and test various models with both perfect golden sample food waste data and the stuff that you see day to day, just like in the back of a grocery store. And actually, a lot of this data we actually got from Google. Google X ran a project years ago where they were collecting data throughout all of Google's cafeterias worldwide. And they didn't end up doing much with it, but like we've been, through our partnership.
We're waiting for you.
We're waiting for me to come and do this. So here we go. Let's go do this. So if we go to here and we take a look at, let's take a look at this model here. So this is a series of basically different models, different data, and like we're gonna benchmark it. This we've all run. So it basically gives you kind of a lay of the land. Like, how do these models compare versus mass estimation, identification, and you say like this guy was an outlier. Let's take a look at this one. And oh yeah, sure enough. Okay, this is a good example. Like we saw it was an outlier. It's saying it can't actually determine the difference between a red apple and a tomato.
Okay.
So it's a great example. Like, and like we're doing this. This is a kind of a simple example. But we're doing this at crazy scale with some of the messiest food waste data you can imagine. I'll pull some of these up because it's fun to check out. So okay. So here's a good one.
So this is looking into.
This is looking into a trash can. So this is like in the back of a Google Cafe a few years back, and we watched them throw some eggs away. And like if you slowed that down frame by frame, a human could have discerned those were eggs. How many eggs were they? How many were cracked? How many were whole? And given that data, how many whole eggs were thrown away? Could we then tell the cooking staff, the chefs, hey, like we wasted some good eggs. Could we have changed the menu that day to not waste those eggs?
That's very interesting. So like replaying that back, it's part of this is actually, using machines to create compost is like number one, but also using this data and insights for agentic processing on the outside to create signals.
That's right. It's exactly what we're trying to do. So, building this new recycling loop is really important, but ultimately what we want to do is by building insights and then powering agents with those insights, can we actually change procurement? Can we actually change menus? Could we help chefs? Chefs spend hours a day on paperwork. And if you talk to a chef, they'll tell you, I didn't become a chef through paperwork.
Right.
I came to cook and feed people.
Right.
So if we could help take away some of that paperwork and say, hey, like, you're gonna have extra eggs today, here's what you could do with those eggs, based on other things that we think may actually be going to waste anyway, what things can you add to the menu? Like, just to give other fun examples, like this is like a terrible example of what you see. So
it looks like a big mess.
Who even knows what that was?
Yeah.
Right? Like, as a human, I could barely tell what that is. So part of what we're trying to do is like teach the algorithms and provide enough labeled data. We have at this point like over 5 terabytes of labeled data.
Wow. Okay.
To be able to really tune these models. This is something that is actually incredibly complex. Let me pull up maybe some of our golden samples here. Some of the towards the bottom here.
Does this, I imagine that a lot of the food that, like, you have this data that you're training or fine-tuning these models on.
Yes.
But I imagine you're getting lots of data potentially from households as well, where you'll be getting this, communication loop where you can continue to train and fine-tune.
So we didn't build a camera into our consumer product. We thought for privacy reasons, we probably should. I've dealt with enough building cameras for people at home to know what goes entails with that. But we have a lot of mass data. We actually know exactly the distribution of what food waste across America looks like, when it happens. We know Super Bowl Sunday is a really bad food waste day. Thanksgiving, also really bad food waste day. But we think about for our commercial applications, we could get much deeper into how those businesses run and give them real insights and actions to actually save real money. About $400 billion a year of food is wasted in the U.S. every year. So massive economic problem.
Massive.
And I think about like the ideal applications of AI. Like this is one that it's not scary. This is one that is just like, it's pure good.
Yeah.
Like it's good for business, it's good for the planet, it's just good all around.
Matt, I, first of all, really appreciate you doing this and talking about this and going into detail. Is it weird for me to say chef's kiss, like on what you're doing? It's incredible.
Oh, we love chef puns. Food and trash puns are frequent around the middle office.
Good. Matt, I really appreciate this again. Thank you so much for being here.